So the first part we're going to talk about is the product training, released to P1. So the good news is finally we made it. So the P1 right now is officially taking orders. Once you guys place order, and a few of the units we have shipped it to the overseas countries. Few of you guys maybe already received it, and more will ship after we come back from Chinese Spring New Year. But we have officially taken orders, so you guys should receive your sensor like very soon. Okay. So next page, this is the DJI P1, the product like overview that we have. It's a 45 megapixel camera, which has a full frame sensor, and you have choice to choose from 24, 35, and 50 millimeter lenses, based on your different tasks and projects. And 3-axis stabilized gimbal can control the aircraft, and also the cameras, all in very stable ways to capturing the data and ensure the accuracy and reliabilities and data qualities. Okay, let's try to use full screen first, because in the morning when we had a session, when I switched to the full screen, the PowerPoint was stuck at some page, but let's try that again, okay? And I will post in somewhere to see if that successfully goes through. All right, so let's go on full screen. So which lens come with it? Yeah, good questions. So when you purchase P1, it will come with a 35 millimeter lenses as default ones. If you wish to purchase different lens, you need to purchase this separately. For example, if you want a 24 or 50s, you just place that order separately, and that's it. And this is the DJI first photogrammetry, full frame photogrammetry sensor. And a couple of things that we keep in mind. One is this sensor can only work with M300 RTK, so do not put it on the M200 series. It will not work. And also the lens. One of the frequent questions that people always ask is, can I use the lens from X7 with the P1? The answer is no, do not do that, because if you put a lens from X7 on it, most of the functions will not work properly. And also, potentially, if you use that lens to fly the missions, potentially if it caused any damage or risks, it may end up no warranties for that. So do not use lens from X7. So how can you differentiate the lens from X7 and P1 is the lens that for P1 will have the enterprise logo on it. Make sure that find the lens that has enterprise logo on it for 24, 35, and 50s, okay? And we're talking about a full frame sensor with 24, 35, and 50 millimeter lenses. We're talking about data qualities, efficiencies. So in this camera, with no GCP cell, we're able to achieve at the minimum, like horizontal 3 centimeter and vertical 5 centimeters. And the high efficiency means that every single flight that the P1 are able to capture, the area that's around like 3 kilometers per square. Okay. It's stuck on slide 3. Are you guys able to see me to change my slides? Okay. Yeah. See, let's go back to the how about now? Are you guys able to see I'm changing my screen. Okay. All right, cool. Let's go. For most of your questions, I will answer that once I finish my presentation. So don't worry, I will get back to you, I guess, later. So it's in slide 4. So basically, within all the features that we have, this one are able to deliver a very good accuracy, high quality, and efficiency results. And then this is when talking about the sensor size, right? Because always people saying that the bigger sensor size, the much more efficiency that you can get. So by combining that, we're talking about more than 5 to 10 times like efficiency compared with the P4RTK for both also and oblique mapping missions. And even the intervals that we're taking images, that this one is around like 0.7 seconds per images that you can take. Timesync 2.0 is also upgraded from P4RTK as well, and I will introduce that later one by one. So this is the assure the high accuracy, the Timesync 2.0 system. So what it does mean is really we're taking the time like records and the middle exposure period of time, and we believe this is the most accurate time. So we're gonna use that time to synchronize camera, gimbal, flight controllers, and RTK modules together. And this is the unique features that DJI can offer, and other rest of companies, there is no company can do this. The real-time composition means that UAV positioning and orientation offset compositions, we actually compose to the center of the camera, CMOS center. And also we do the gimbal orientation offset compositions and camera position offset composition as well. And that's why by combining those all together, we're able to deliver a very good accuracy results. The lens that we talked about previously that you can choose from like 24, 35, and 50s, right? And 35 will come with default. And make sure that you use the lens for P1, not for X7. And the way you can differentiate is that for the lens for P1 will have the enterprise logo on the lenses. And this is the equations to calculate the GSDs. So for example, like we're talking about like 35 and 24 and 50 millimeter GSDs. That's the equation that you can go. Let's see that if we want to have like 3 centimeter level GSD for the P4RTKs, I'm gonna fly like 120 meters. But when we're talking about, for example, like 35 millimeter lenses, we're talking about really basically 240 meters that I can fly. So in this case, I fly a lot higher and I have much better and much bigger sensor size, and much longer flight time. And it all come together means that we're gonna have much better efficiency while flying the P1 there. And also this is the some tips, because this camera you can actually change lenses, right? So press the buttons and you're gonna change the lens. But my recommendation is do not change the lens only if it's necessary, okay? Because when you change the lens, it may have some like minor like shift and adjustments. So every time when you change the lens, you have to redo the camera calibrations to make sure that you have the best and utilized camera parameters there, okay? And one of the extra topic I want to share with you guys is the vision for DJI. We're talking about geospatial products right now. So you see the efforts that we actually are willing to invest into these industries. The little triangles are already start to build up. So we have the base products, which is the P4 series, P4RTK, P4 multispectrals, and P4 Pro. And the core for that level is the P4RTKs. And we still believe that's actually the most important products that we ever have, because that product is the one that we actually spend and invest our R&D resources into it, and to make sure that we develop the timesync technologies and talking about the photogrammetry terms. And we believe that still this product is the core products that we want to make sure that our channel partners can together with us to make the cake a lot bigger, to sell and to promote and to educate the markets using that products to all the potential customers there. And then for the advanced level customers that we can recommend them to purchase the P1. For those of people who are already familiar with aerial photogrammetries and they have much much larger budgets and they want to do a much larger job site, and the P1 is the one that they can choose. But like I said, the triangle is already there. And we have like L1, M300 RTKs, and DJI Terra. I'm sure that in the future, we're going to invest more and more in this industry and field as well. So yeah. So this page is it's talking about P1 lens parameter calibration workflow. Please look this page carefully because I'm going to teach you guys how to do the camera calibrations right now. So basically what you're going to do is first of all make sure that you have a DJI Terra and the version is above v2.32 or above. You can download the latest version from DJI official websites as well. If you don't have lesson, just go ahead and ask yourself, Rap, apply 3 months DJI Terra 12 account, try it first. Or you can simply ask your customers and help them to apply 1 month free code in DJI websites and to get the DJI Terra account there, okay? And other than that, once you have the account ready, so what you're gonna do first is using DJI Pilot to plan a mission in a not flat area, means the area has terrains and always have like fluctuate landscape changes. Then you either do, for example, like smart oblique captures or the oblique missions, like directly, and take around like 100 images in the field areas, oblique images, what I'm talking about. Then import your mission images with your oblique images together into DJI Terra, and then you process it using 3D modeling ways, okay? So when you processed it, when the mission was finished, so what you're gonna get is a directory called like AT report, and you can find the file called SMF report. So you basically simply put that file in the SD card root directory and plug the SD card back to P1. Then power on the P1. The calibration file should automatically written into P1 camera system. Okay, so now you have the latest and utilized camera parameters there. The way to check it is make sure that you can take some sample images and open it a TXT file and search for XMP. Make sure to find a DROP data parameters, and you can check that the parameters was successfully written or not. Okay, and one more thing, please keep in mind, and that's why I basically tell you guys that many times. If it's necessary, do not remove and swap a lens, because if you do that, the parameters may change. You have to redo that procedures again to make sure that you have the most accurate camera parameters there. Okay, so that's how you do the camera parameters, the utilization there. And this page basically tells you another unique feature called a smart oblique capture. So what it does basically is, in the past, if you have a single camera, right? So you have to fly the area using oblique missions. That means that you're gonna fly the area 5 times and take lots of images. So it will waste your time and basically reduce the efficiency. So by having the smart oblique capture means that it's a 2D map, right? Yes. But while doing the missions that you're talking about, you want to have some like oblique images for you to do a 3D reconstruction, then that's fine. So simply turn on the smart oblique captures and circle your mission areas. So then based on the areas that you want to do your missions and collect the data, it will take the images in that directions only if it's necessary, means they're facing directly to the mission area, right? So right now you see these pictures that has all the directions, right? Means that in edge areas, I will only take images. For example, on the left side, you see all the directions are facing like internally. No directions for the externally, images, right? So means I would take the images in that directions. And also the flight speed may also adjust as well, means that while the drone was flying and taking images, and it will fly a lot slower. But when there is no need to take any images, and it will fly a lot faster. And on the left side, you see we're talking about in the area, for example, in the red circle and that the red triangle areas, right? So rectangle. Sorry, my bad, rectangle. So you're gonna see that the area that was the 5 directions, the flight time will reduce to 3.3 meters per second. But when we're talking about only the austral images, I will just fly like 15 meters per second. I'm gonna show you this video real quick, then you will know how it works. So now the drone starts to do the missions. In the center areas, the camera is actually swing to 5 different directions, then go to the edge areas and take only 1 images. And also inside it takes like 2 images and 3 images and 4 images and with different speed. You see when that goes to the area that no need for taking any images or maybe 1 images, the drone will fly a lot faster. So that's basically how that works. And it will save lots of time, not only by mission side, but also reduce the image quantities. When you process it in software, you can also get much better speed as well. And also another one is feature smart data like management. It's really similar like the P4RT case. Basically, you have all the the metadata and camera parameters and RTK stats, also informations, and written with the images. Post data all together with images, and it's really just very convenient tools that when you process the data, you don't have to merge the post data and other information together with images because you already have that in one. We're talking about MRKs and GPS like satellite observation files. That's the same idea like the P4RTKs. You can really use that data and import it into the third-party PPK software to process it and to deliver the best results. If you wanna prefer a PPK way, and sometimes because in an area that it has a very strong like magnetic interfere, so RTK may lose connection, so PPK may become an ideal way to do that. Okay. So those are a recommendation table of the settings for different lenses and heights. Just give you guys a reference when setting up the P1. But my personal opinion is this: just once you have the sensor, just do it by yourself and experiences it, and having more hands-on experiences, and then compare with this sheet. So you will have much better idea on how to operate it and what's the best settings for your localized mission. And when talking about SD card, and this is the important part because the image are much larger and you take more images in a very short period of time. So make sure that you have a SD card, high-speed SD card, and speed requires are UHS-1 or faster. Okay. And when you purchase P1, it will come a default with a 128 gigabyte high-speed card, but it can support up to 512 gigabytes. Okay, and the micro SD card is not really for daily operations and data collection. It's more for troubleshootings. It will store the export gimbal logs. User can extract the log for after-sales troubleshooting when there is any issue occurs on the gimbal. So make sure you can always use the high-speed card. Otherwise, you may have a chance to lose the images during the missions, right? All right. So also one of the unique features that this one have is it's called a field report. So what it does is basically in the past where we're doing the missions, you always have to go back to the office and check the qualities of the images, and now you will see whether it's good or bad. If it's bad, you have to find another time and go onto the field and to recollect the data and doing the work. But it's really not ideal, right? So by having the field report on the side, you are able to check the quality of your work, the RTK positioning stats, and local location accuracies, and those informations, images that has taken. So now you have a overall idea of the quality of the missions. If it's not okay, then you can do it right away again. Okay, and real-time mapping is one of the features that we will support in DJI Terra, just like the P4RTK for sure. But now it's not yet ready, but it will be there in some point. And payload health management system is just like M300 RTKs and with other DJI payloads. So you can check that with all the information there and to do the maintenance. And the workflow for this one is Very simple. So what you need is a DJI M300 RTK. Flight control app, which is DJI Pilots. You can use that to control, for example, and to plan like waypoints and photo mapping, oblique and corridor missions, right? So that's all we're gonna do in DJI Pilots. People may ask where I can find a smart oblique capture missions. It's actually inside of the photo mapping, okay? So inside of the photo mapping, you are able to find a function called a smart, oblique captures there. So data processing said we highly recommend that use DJI Terra because we integrate DJI Terra in best ways for efficiency, model qualities, and ways to do the camera, parameters in utilizations as well. But you can still use third-party software to process it. So when we're talking about workflow, those are the key components that we have, right? So Pilot, M300 RTKs, P1, and DJI Terra. 2D also is just like, most of the 2D also missions that we have. It's very simple, right? And 3D oblique side, you guys already noticed that. And, the detailed reconstruction means that within a safe distance, we can use, the M300 RTKs to fly close enough into capturing the details and inspection works and modelings. And we have some case studies later on. I can show you guys that as well. And this is comparison sheet between the P1, X7, and P4 RTKs. So in simple words, I would say for now, please do not recommend M210 RTK with X7 to the customer anymore because this solution has no future. One is the price, maybe it's a little bit competitive compared with the P1 and M300 RTKs, but other than that, it's really just not a good solution anymore. Efficiency, data quality, accuracy, and future support and investment are all gone basically. P1 will be the one to replace that. Also, we have the P4 RTKs, which is on the bottom, so you can use that to transfer and expand the cake into a larger scale. So we have that 2 camera systems there for the photogrammetry. And later on, we're gonna also introduce you guys L1 for another type of the missions. So from the specs that you can clearly see that, for example, like shortest time interval and pixel size, effective pixels, flight height, flight time, basically everything that P1 is just a better tool there. Also, again, do not use lens for X7 for P1. It's different. And those are some specs. I'm not gonna just read it. You can have that, into our websites, and all specs are there. You can check it. And those are some common questions that people may ask while operating the P1. And make sure once you solve those problems, you should make sure that you know how to answer that. So question 1, the estimated flight time and estimated photos are higher than actual values, and that's normal. So it's estimated, right? So right now, when we're planning missions, we figured that the actual flight time and images are smaller and less than the estimated time and images in DJI Pilot, and that's okay. For example, in DJI Pilots, if you see like 1,000 images and 55 minutes flight time, well, it actually ends up, for example, like 800 and 700 images. For example, like 40 minutes flight time, it's okay, it's normal. It really just an estimation parts, and we're trying to make that more accurate right now. But it's really the situation right now, but that really doesn't bother you guys. Also, a second part is when you use 24 and 35 millimeter lenses. When you take images, some of the images may have a landing gear in the images, and that's okay. It really doesn't impact the data reconstructions. We'll import that data, the images that contains landing gear, into the software to process it, so we can remove that, and it really don't impact your accuracy and results and quality. So don't worry that. Even in the images you see the gimbal gear, it doesn't really affect anything. Another one is called getting a warning message called a gimbal reaches to its limit when the wind speed is too fast when using a smart oblique capture features. So in this case, again, ignore it. This will not, affect quality and accuracy for the reconstructed model. Just ignore it, and that's it. Warning message: gimbal overload. Well, using oblique capture features, right? So by having that, expect the the oblique angle would be like maybe from like -2 to 3 degrees compared with the preset angle values when it's the warning pops. This will not affect actual use, means that ignore it. Missing photos or app warning message SD card system file load failure. So format the SD card. Use the DJI app camera setting page. Do not use low speed SD card, like I said before. Make sure to check our product website specs page to check the speed requirement on the SD card. And last one is when resuming a smart oblique capture missions, P1 would capture 5 direction photos on the next waypoint regardless. This would not affect the quality of accuracy of the reconstructed model. However, this would slightly affect the efficiency. We will utilize that in the future, but now it really doesn't bother the quality, sir. It just slightly impact the efficiency there. So those are some common questions. Okay. Let's go to the application sectors. So the P1, it's a great tool for topography, like topographic survey, cadastral survey, AEC, natural resources management, geological disasters, and emergency mapping services, okay? And this is one of example that I just mentioned for the detailed inspection work and modelings. So this is the side of the mountains. So sometimes when we're facing those type of the features, that we have to do the inspection works, make sure that there is no rocks falling down to the rivers and crash on the boats and things like that. So in the past, people has to climb on the mountains and to inspect it, and it really time consuming and super dangerous, right? But by having the P1 and M300 RTKs, we are able to scan the side of the mountains using machines instead of the human beings, right? So it's high resolution, it's high efficiency, and save lots of time and high accuracy as well. So this is the model that we get for the side of the mountains. So now you see that you can really see the 3D model qualities by zooming. You can even see the nets that is actually covered of the mountains. Make sure that there is no rocks falling down on the river, and we can do the inspection works. You see this is a great tool, right? So it's really powerful for those type of mission there. And also, the P1 is another, it's a great tool for a large area modeling and mapping, right? So in a sunny day, in this example, actually, we use the P1, and we set overlap ratios to 55 on the side and 75 on the front. Because of the sensor is much larger, so we're able to reduce the overlaps. And another thing I want to let you guys know is at the beginning, when you're facing a very sunny days and crystal clear skies, most of the time the default settings of the P1 in DJI Pilot should be good. So leave it as default, and you should be able to get the good results. Okay. So this time they're using the smart oblique captures, and area that we mapped is around like 3.8 kilometer per square, and we fly like in total we fly like 87 minutes and 3 flights and over 2,000 images. Then we have this very beautiful map there. And this is another example, which is in Shanxi province. Also we fly, for example, like 3 centimeter level GSDs, and the overlap are a lot higher. And again, this time we took around like 6,000 images, and flight times like 9 times. and data processing only took like 9 hours, and we have this map there. And those are, when we're talking about accuracy, right? So, the accuracy, we place the GCP there. So we only use GCPs as checkpoints to measure the accuracies. For both horizontal and vertical, we're able to get very good accuracy with no GCP at all. So now you're going to see, those large area DOMs, the details, the resolutions that we have, and the map quality there. And again, this is another example of a very large mapping missions, which is 65 kilometer per square. We're talking about 1 to 1,000 topographic projects. The drone was flying like above sea level around like 263 meters. And we're talking about 60% side overlap and 80% front overlap. And the map areas cover like 65 kilometer per square, and we fly this area like using like 3 days, and images were more than like 21,000 images there, and DJI Terra processed using like 48 hours. And computer is just an average and quality software computer for processing like images like 64 gigabyte RAMs, and NVIDIA like GTX 2080 Ti and Intel's i7s, and you have this map there, a very huge and large ones using P1, and you can see the model quality there. So this is another example, it's 3D missions, right? Using oblique missions there. Comparing with the, for example, like traditional oblique captures that, when we're using smart oblique captures, basically that is only 1/3 of their total photo amount by using like 5 direction oblique camera payloads, right? Less images, same data qualities, and a lot much better efficiency compared with the single camera system as well. And this is another like missions, like radar type of the missions, which is 95 kilometer river demarcations. You see the mountains and side of the roads. So this radar project is located in Jiangda County, to Tibet, and by also it's a very extreme operation environment under sub-zero Celsius degrees, and also the high altitudes, but combine all the factors that P1 and and M300 RTKs are able to achieve the missions in a very solid way. And this is another example from one of our like German channel partners, right? So it's they're using that for like recreational and like environmental monitoring purposes. So they use that to monitoring and capturing, for example, like the dot areas with all the sandals and the erosions, and natural resources, and lives and creatures, and also using that to reconstruct the, for example, like 3D modelings and buildings around by. So because the drones can fly a lot higher and it really doesn't bother the feed creatures, you can really observe, just doing the observation works, for example, like all the wastes on the land, the erosions on dot areas, and all the birds on the ground, all that's all what you can take. And really monitoring the human impacts and natural resources management there by using this tool there. This is another models by using P1 to reconstruct the natural resources departments and their buildings, right? And if we zoom to more details, then you can see all the model qualities and all the details that the streets, pipelines, you know, it's just all at very high quality there. Yeah, so that's really about P1.